Welcome to the Aftercast for episode 15. So let's share our screen and we'll get this episode started. All right. So hopefully everyone enjoyed themselves a wonderful May-long weekend. And the Aftercast is the video presentation of the podcast. So welcome to the Aftercast. So before we begin, though, we always need to recognize our sponsors and start off with a nice big cup of, well, in my case today, Island Medium Roast from Ohana Estate Coffee. This again is a small local business based in Edmonton. They import beans from Hawaii and have a number of different flavors. Yes, coffee grown in Hawaii. So, why don't you go online to their website, ohanacoffeeco.com. That's ohanacoffeeco.com. And order some coffee, grind up some beans, enjoy a great cup of coffee, and join the Ohana. Because Ohana means family, and family means the coffee is always on. So in this month's podcast, and obviously here in the Aftercast, our topic is the economics of HVAC. So what do I mean by that? Well, a lot of people think, well, I have a service contract, therefore I know how much I pay, and that's what I spend on HVAC. But really, it's just like the tip of the iceberg. There's so much more to what you spend. So what we're going to go through today is the process of raising awareness to the economics of HVAC. So there are many things we need to consider. There is the cost of owning the equipment and the cost of operating the equipment. And what we're going to do first is we're going to delve into the costs of operating the equipment. So like the iceberg, there are parts that you see above the water, right? So we mentioned the contract's the tip of the iceberg, but there's more to it. So things like small parts and tools that can be used. Perhaps you've seen on an invoice things like recovery, combustion analyzer, perhaps scissor lift's not part of that agreement, so you may get charged for that as well. Then there's always major repairs. As they do their maintenance, they may find things and there are repairs to be done. So those major repairs are part of your cost of operating. And then, any service calls on top of that. And most invoices have a truck charge on them as well. So those are all parts of the cost of operating that you see as part of the iceberg. That's above the water. Those are our tangible items. You have bills for them, and you can actually see the dollar value that's associated with them. But let's delve a little deeper. Let's get into the water, if you will. And what don't we see? What's that part of that iceberg that we don't see? Well, energy waste is one of the things to consider. Studies indicate that energy waste can take 41% of what it costs to operate a commercial facility. And that's from the Department of Energy, Office of Conservation and Renewable Energy. And in some conversations I've had with vendors and suppliers, they say now it can be closer to 50% because lighting, for example, there's new lighting technology, so it's reduced the amount of energy consumption there, and therefore, everything's shifted in this graph you see here, and it can be as high as 50%. But for what we're going to talk about today, let's just say it's 41. It's a conservative number. So what can contribute to those energy costs? Well, not just using the energy, but sometimes energy can go up because of things we find in a facility. So when we begin working with clients like this, we do mechanical inventory, and it's just more than gathering model numbers and serial numbers, which gives us capacity and age, but it's identifying things as we go through. And here's some examples on this slide of dirty filters. You can see that filter is so dirty and has been in that metal frame for so long, it actually has become overweight and started to fall down in that frame. That filter hasn't been changed in a very long time, and that contributes to energy consumption. Also, a dirty evaporator coil. Equipment now needs to work harder to bring the air across the coil, so energy consumption increases. And then things like missing pulleys and belts might be some things we find. So now you've got things just running, endlessly and not serving any purpose. So again, these are things that we look for when we go through a facility as we begin this process of making clients understand what their economics of HVAC really are. So the Department of Energy, now let me clarify that, the US Department of Energy says by being truly proactive and taking these steps to do coil cleanings, making sure belts are properly aligned, replacing filters at the appropriate time, proper burner efficiency, removing soot from burners, and making things sure items are operating in the proper sequence and are adjusted accordingly per season, there is a potential energy savings of 5 to 25% just by being proactive in maintenance. So how do we quantify this? Well, typically when working with a client or customer, I ask for the last 12 months of gas bills. And then once I gather that and create a total, you multiply by the US Department of Energy. So based on what you saw, what would be the achievable return that they could get, potential energy savings that you could provide them? And it all depends when we do our site visit, right? So depending on what we find. So, typically that gives us our cost for potential heating savings. On the cooling side, it's a little more complex, but all we need here is cost per kilowatt. And then based on the total cooling tonnage of the facility, identifying the type of cooling equipment you have, whether it's air or water cooled, or if it's a packaged, split, centrifugal, or reciprocating system, and the number of weeks per year that a cooling system operates, we can use this calculation to now identify the potential of savings that you have on cooling your equipment. So that's the first thing under the water, is the potential energy savings on your heating and cooling side. There are also downtime losses that we need to consider on the cost of operating. Well, what's involved in downtime losses? Well, every facility is different. So grocery stores, loss of product. If they can't sell their product, they're not making money. So they need their refrigeration systems up and running as quickly as possible. Production, you go to any production site, and if their HVAC equipment is tied into their production, like keeping things at a certain temperature, they can tell you exactly how much it costs per hour if that equipment goes down. So they are well aware of their downtime losses. Property managers, there are studies that show that if there's a number of heating and cooling complaints with a tenant over a period of time, they won't renew their lease. So now it becomes a cost to find a new tenant. So their downtime equates more to tenant retention. And business owners, even just employee efficiencies, making sure they're comfortable. There are studies out there that calculate how much time is lost due to inefficient workers just because of comfort. So those things all tie into potential downtime losses. So that's the next item to consider under the water on our iceberg that we don't typically see or take into consideration. The next thing is administration. Administrating service contracts can take a lot of time, or even just looking at the invoicing. There's the cost of issuing purchase orders, then matching it to invoices, cutting the check, and there may be multiple invoices involved as well, and just even sometimes administering the work that's been done because of various systems and tracking systems that a customer may have. I worked with one client. And going back here, so going back over 20 years, in 1998, to process a single invoice cost them $125. A single invoice. So you can imagine the cost of administering an HVAC contract, depending on the number of invoices they received, it could have been quite a costly thing. So administration is one of those things, again, on the iceberg, under the water, that you don't see. So we've considered your outside services, your service contract, small repairs and tools, major repairs. Those are the things you see above the water on the iceberg. And then the things you don't see: energy waste, downtime losses, and administration. Those are things that are under the water on the iceberg, the things you don't see, but are costing you money. It's part of the economics of HVAC. So what's next? Well, the cost of ownership. Owning the equipment, there's a cost associated with that as well. So to help us understand what the cost of ownership is, to quantify it, we need to consider the American Society of Heating, Refrigeration, and Air Conditioning Engineers life cycle chart. So ASHRAE. ASHRAE is the standard across North America, and it has given us an average of life cycles for these pieces of equipment. So for example, heat pumps, 15 to 19 years, air conditioners, like window units that you see sitting in windows, 10 years, and then rooftop air conditioners, an average of 15 years in North America. Well, why is this important? Well, once we identify the current age of your HVAC equipment, which we've done through our process of gathering model numbers and serial numbers, we now compare those to the ASHRAE life cycles. And then we do a calculation to give us the remaining life left. And then we take the tonnage or the cooling capacity of your rooftop units, heat pumps, and come up with a total number there. And the research tells us, based on the type of cooling you have, how much that costs per kilowatt. And then we calculate the cost of replacement based on other averages, and then it gives us the total dollar value. So that is now the capital costs. That is the deepest part on the iceberg, you might say, because that's usually the largest dollar amount. So again, now put all those things together. That's your complete iceberg. The total costs of owning and operating your HVAC equipment. So you're probably wondering what that looks like. What's an example? So I'll show you an example of one calculation I've done recently. To put it all together, as you can see on this slide, their contracted services were just under $2,000. They spent nearly $20,000 in major repairs. Going through those calculations, as I mentioned, we identified the potential of saving them about $4,600 in energy. And because their equipment is at the end of its life, an amount of cooling capacity that was involved, their cost of owning that equipment is about $62,000. So what does that mean? That means if they were to replace it all today, or what they need to budget today to replace that equipment, is actually $62,000, which gave us a grand total of $88,486. So this whole pie represents $88,468. So this customer could say, I know my economics of HVAC. I have a service contract for $1,946. Again, tip of the iceberg. So through this process, we've identified that it's actually $88,486. So what I'm going to demonstrate to you now is two triangles. The first one is what I call the triangle of despair. And at the tip of the triangle, there was little planning by the service contractor. They probably were chosen because of the cheapest price. And over time, they've had hot and cold spots, some premature equipment failure, increase in service calls, endless repairs, increasing energy bills, perhaps employees having increased sick days, premature equipment replacements, multiple invoices, downtime costs, exceeding budget, endless frustration, systems not working, discomfort. And at the end of the day, they get all of that for the low, low price of $88,486. Is that what you would like? If you ran your facility, would you like to have all of that? Hot and cold spots, equipment that doesn't work, equipment that's not reliable, and you're only paying $88,486 for it? Well, of course not. That is ridiculous. And let's just say the triangle here, the triangle of despair, represents that $88,486. So by going through this process and realizing how much they are currently spending, what their economics of HVAC truly are, we create a program. We're not going to let that iceberg take you down. We create a program based on that. So again, we're just going to flip the triangle over. This is the triangle of repair. And that triangle still represents $88,486, but it's how you're spending it now. With this type of approach, it is designed to be equal to or less than the $88,486. And if you could get something better that provided you with comfort, that meant your equipment was reliable, for equal to or less than what you're currently paying, wouldn't it make sense to seriously look into it, consider it, perhaps even go forward with it? So as we flip the triangle upside down, you can see there's a lot of planning in the beginning. And this takes into account the operation and runtime of the equipment, the age, the environment that's in the facility, the environment that is around the facility, the energy usage, and the manufacturer's recommendations for maintenance. Then we assign a team, we designate an account manager, we assign a technical team, foreman, and one or more technicians. There is an on-site kickoff meeting where we all get to meet, understand what's involved, and the requirements of both the customer and the contractor, and then to execute this personalized plan to ensure that things are reliable, efficient, and dependable, and ultimately there's reduced downtime and comfort. So at the end of the day, you're not spending tons of cash, but there may be a little bit of additional expenses. But the idea is we're taking that dollar amount and actually making it work for you. So would you like to spend the $88,486 and not have comfort? Have equipment breakdown? Have equipment not be reliable? Or would you like to spend equal to or less than and have comfort environment, reliable equipment, reduced downtime or no downtime? Of course, we don't say that's what we want. Now we need to demonstrate if what we're going to do is equal to or less than what you're currently paying. And when we prepare a program like this, we include things like supplies and materials, all tools and test equipment, parts replacement for all moving and maintainable components, all labor, emergency service, program administration, and there's a fixed operating budget for you as the client to ensure that you're paying equal to or less than $88,486 to have the equipment actually having your money work for you, providing what you desire. So it was once stated here on episode 1, by providing a program like this, or what the industry calls full coverage, comprehensive, all-inclusive, it should be an extremely high-quality preventative maintenance program that also provides protection on failure. And that was stated by my first guest, Mark Ollinghouse, who has been doing this for years and teaching the economics of HVAC. So in this example, we went through all those calculations. And at the end of our presentation, we presented with a plan that was literally just shy of $20,000. So they had a potential savings of nearly $70,000 with going with a program like this that addressed all those things and would ensure that they had proper energy efficiency, maintenance would be done on a regular basis by the right technician at the right interval, that there'd be potential for energy savings, and just basically their headaches would go away. Now, this type of program is available to everyone. And, if you're interested in even looking at this and considering what your economics of HVAC are, what your true costs are of owning and operating, I'd be happy to help you out. Just reach out to me at thatbighvacshow@gmail.com, and I would be happy to meet with you and provide you a chance to see what your economics of HVAC truly are. I'd also like to remind you, if you liked what you've seen here on YouTube today, that you subscribe, like this video, comment on it, and even share it. I'd really sincerely appreciate that. That Big HVAC Show is the podcast. It's your podcast. Is there anything out in that big HVAC world you'd like to learn more about? Please let me know, and I'd be happy to research it, interview the right people, and share that with you. So until next month, dream big, work smart, and be safe. Oh, and one more thing. I always end the podcast with the one more thing. Might as well end the aftercast with that. So in 2018, I was on holidays in Cabo San Lucas, hanging out at the Cabo Wabo Cantina, and the staff referred to me on that visit as the mayor. So I am the mayor of the Cabo Wabo Cantina in Cabo San Lucas, and when I returned the following year, that's how they referred to me. The mayor has returned. So that's just one more thing. I'm that big HVAC host, Dwayne Anderson, and thanks for being part of today's Aftercast. Have a great day.